Good morning, Srinath. Good morning, Ganesh, Rishabh. Are you only 48 are connected? What about remaining? Venkatesh, inform in your group. Ask your students to join in the class immediately. Okay. Good morning, Nikita. Again, today also. Is my voice low today?
Yes, ma'am, it's
Yes,
low.
ma'am.
Mm-hmm. Okay, let's start switching techniques. Switching techniques. Mm, Introduction. I think I have given introduction of switching, right, in the last session. Anyhow, we'll start from switching introduction. So for large networks, when we are surviving in a large network, then we used to have a long path to send the data from one system to another system. We might have the long path. So the switching technique which enables us to find out the best route, otherwise the optimal path to traverse from one system to another, to traverse the data from one system to another system. That's the use of switching technique. Switching technique, which is used to connect the system for making a one-to-one communication. There are different classification of switching. Circuit, message, and packet switching. Circuit switching is further classified into space and time, and packet switching is classified into datagram and virtual circuit. And again, which is the virtual circuit, which is classified into circuit, switched virtual circuit, and permanent. But I don't go in depth for the virtual circuit. Okay, let's move to the circuit switching. What is circuit switching? Circuit switching, which is a technique that establishes a dedicated path between sender, as I said earlier. So this is going to provide a path, right? By using the switching technique, we are going to find the optimal path for transferring the data from one system to another system. That's the use of what? That's the use of switching technique, right? And so when we go to circuit switching, actually the circuit switching which establishes a dedicated path, right? It provides a dedicated path. Otherwise, we can call it as a channel between the sender and receiver for data transmissions. Once the dedicated path is established, then then the transmission path, then we can transfer the data, right? So that the messages can be transferred along that path, right? And the path is not terminated until we disclose the connection, right? The path will be dedicated. As long as the data is forward, the path will be dedicated. Once we finish the data transfer, then the path is closed, right? So circuit switching, we will be having a dedicated path from initial till the end, right? From the start till the end, right? We will be having a dedicated path from start to end, right? And we can say that in circuit switching, so there is a dedicated communication path, right? Is established between two end systems, between the two systems, and which remains open till we close the till we disconnect, right. This is similarly like how we are making a telephone call. Once we start talking until we finish, then the connection, the dedicated there will be a dedicated call, right? So similarly, like so circuit switching, which is the best scenario, yes, how we are making a phone call to others, right? So there will be some dedicated connection established between the between you. If you're talking, then between you, right? Between you and your friend, right? To the other end, right? To other end person. So there will be some dedicated link which is provided for making the call, right? So it is similarly like the circuit switching. So there is a dedicated path, right? So the dedicated path will remain to exist until the connection is terminated. So circuit switching is similarly like a telephone networks, and a complete end-to-end path must exist before the communication takes place, right? And so once think of that, you are sending a data, voice or video, a request signal is sent to the server, right? A request signal is sent to the server, then receiver sends the acknowledgement to ensure about the availability of path. So once you want to send any data, right, look at this. Once you want to send any data, initially you are sending a request, right? Think of that, A is sending some messages to the B, and there are some intermediate nodes in between A and B. The call request is first initiated from the sender A who wants to send the data, and once the request is accepted, the accepted by the receiver B, then it has to send the call accept message, right? And then, so this is like an acknowledgement that is given for which is to make sure about there is a dedicated path that can be established between sender A and B, right? So after receiving the call accept message from the receiver B, the data transfer has been taken place, right? The data transfer can be done, right? And once the data, so this is the acknowledgement which is given by the receiver upon receiving the messages from A, right? And once it finishes sending all the data and messages, datas are messages, right? Once it finishing all the data and messages, then it can send a clear signal if it wants to disconnect from the receiver B, otherwise the node B, right? So this is the form of communication that has been taken in circuit switching. Is it clear, ma? Is my voice audible now? Is it audible?
Yes, ma'am, it is.
Okay, pa, okay. So next, how the communication can be established. There are three phases. One is circuit establishment, another one is data transfer, and then circuit disconnection. So there are three stages of communication, three stages of communication establishment through circuit switching. One is circuit establishment, another one is data transfer, and circuit disconnection. What is circuit establishment? Circuit establishment is sending a requesting signal, right? Sending the A sends the requesting signal. You can look at the scenario. A sends the request signal. So once the B receives that request signal, then it sends the call acceptance. So thereby it ensures about there is a dedicated path. So you can use that. There is a dedicated path established between A and B, so that the data transaction can be proceed, right? So this is like a acknowledgement which is given by the receiver B for the dedicated path, all right? And once the acknowledgement is received by A, then the data transaction is performed, right? So this is called data transfer. That is called data transfer. And what is about circuit disconnection? Once it finishes sending all the messages, then it can send a clear signal. The sender A can send a clear signal to the other end system. So thereby receiving the clear system, the dedicated path is disclosed, right? So this is called the third phase, circuit disconnect, right? And circuit switching can be further classified into two. One is space division and another one is time division, right? One is space and another one is time division. Actually, in space division, which can be established via two ways, space division and time division. In space division, so which is one kind of a circuit switching, and which is used for analog and digital networks. So in space division, while performing the space division, there are two switches that can be used. One is crossbar and another one is a multi-stage switch. The crossbar, which is similarly like n inputs and n outputs, like a matrix. You can think of like an image like a matrix. So it will be consisting of rows and columns, and each rows for
Excuse me,
one
ma'am.
cross. Yes, ma. Is it
Ma'am,
not
your voice
audible?
is not audible, ma'am.
Uh-huh. Okay, for space division, see, I'm talking about space division. See, up to it is clear. Up to this slide, is it clear, ma? Shall I have to repeat the slide again? This slide? Shall I need to repeat? No. Shall we move to another slide? Next slide. Yeah, what else? I don't understand what this no means. Shall I need to repeat it?
No,
Ma'am,
ma'am, it's
you
clear.
repeat
You
it
can
once.
go
Okay.
to the next slide.
So
Oh,
okay. Okay, ma'am. Good. Thank you. So space division switching, right? Space division switching. Space division switching can be can use there are two types in space division. One is crossbar and another one is multi-stage, right? So space division switching, which comes under circuit switching. There are two types in circuit switching. One is space division, another one is time division. And again, space division is classified into two. One is crossbar and another one is multi-stage. In crossbar, you can think like a matrix. So it is splitted like a matrix, rows and columns, and each row and column there will be a switch. So there will be a switch so that it is given as n input lines and n output lines, like a square. You can think of like a square, like a tabular column. How to represent this? Yeah, wait. So it is given as n insert.
voice is low, ma'am.
Yeah. Okay. So this is like a table slide, right? Like a table. See, on each, so when rows and column is, so there is one meeting point between a row and column, right? So for first row and first column, so there will be a switch provided here. So there will be, for every cross point, there will be a switch, right? So you will be having number of cross points, and every cross point, there will be one switch attached in it, right? So this is, for example, I have taken this
Excuse me, ma'am. Ma'am, your voice is very low, ma'am.
very low. Mm-hmm.
Ma'am, is there a way to bring the mic closer? Then it will help because sometimes the voice picks up higher.
Uh-huh. Actually, I'm having the mic very close to my mouth. I don't know why. See, with the same
Ma'am, or
tone.
unplug the mic, ma'am.
What, pa?
Ma'am, use
What?
the laptop's mic, ma'am. It would be better, I think.
Or unplug the mic, unplug the headphone, and then plug it again. That should help.
Mm-hmm. Mm, okay.
Hello, ma'am.
Sorry for the delay. Is it audible now? Is it audible, Pa?
Yes, ma'am.
Yes, madam.
Yes, ma'am.
It's visible, ma'am.
What?
Ma'am, your presentation is not visible, ma'am.
Yes, ma'am. Your presentation is not visible, ma'am.
Press stop sharing, no? Okay, we'll project
ma'am.
again. Wait a minute.
Okay, ma'am.
Now the voice is fine, no?
Yes,
Yes,
ma'am.
ma'am. Why is it fine?
Okay, okay. Okay, let's move to space division switching. There are two types, right? There are two types. One is crossbar and another one is multi-stage. In crossbar, we used to have n input lines and n output lines, which are arranged like a matrix form. For each intersection, you will be having a one switch, right? And in multi-stage, it is made by the first splitting the crossbar switches into the smaller units and then interconnecting them. So what is the advantage over a crossbar switches? There is if any failure occurs in one path, then there is the possibility of another path. That is the advantage. And the space division switching, which is high, so the speed of space division switching is high, and it has a high capacity, and switching contains the non-blocking switches. What is called non-blocking switches? Anytime, so non-blocking means if it is not deactive, it is always make the connection. That is why it is called as non-blocking signals, right? So non-blocking is a device that can connect n input and n output lines, right? Which is a non-blocking device, and it always makes a connection. So that it is called the space division switching, which contains a non-blocking. It is said to be it contains a non-blocking switches, right? And time division switching, which is a digital technique, and here there is no need for cross points in switching. And here the time division switching, there are no cross points, so cross points won't be shared in space division. Here the cross points can be shared for shorter period of time, so that it is given as it is mentioned as time division multiplexing. So short periods in time division multiplexing, like in time division multiplexing, will be the space will be occupied, right? The medium will be allotted to each user according to the time, right? Like the cross points will be shared. The cross points will be shared over a particular period of time during the transmission, right? So it is going to share the cross point, so that it is so the time division, which is used in modern devices, and it is comparatively more better than space division switching. And what is the disadvantage of circuit switching? So disadvantage, there is once the dedicated path is established, and only a delay occurs in speed of data transmission, and it takes a long time to establish a connection, and it is more expensive than other switching techniques. And let's see what are the other switching techniques, right? As since a dedicated path is required for each connection. So once you want to make a connection, then you have to, if you need a n number of connections, then you need to provide a n dedicated paths, so that it is more expensive, and capacity of the path is wasted once you want to share a small amount of message, right? Small, otherwise the one message, if you want to send a one message, then you have to establish a connection between two devices. So so you have to provide a one dedicated path for that, right? So it is inefficient, and no other data can be transferred even in the channel if it is free, right? So the dedication, so the channel is said to be dedicated, so that no other data can be transferred. Even we have even the channel is free, but the sender not having any data to transfer, the channel is dedicated, right, only to the particular sender and the receiver. And once the data transfer is finished and still if there is a connection exists, then it will be waste of resources, right? So these are some of the disadvantages associated with circuit switching. And next one is the message switching, which is the type of which is the second type, second technique, message switching, in which a message is transferred as a complete unit and routed through intermediate nodes at which it is stored and forwarded, right? So you think of that, there is a device, there is a device A and B. In between, there are multiple devices which are going to forward your messages. Once A is sending a message to the B, in between there will be number of intermediate nodes. Those intermediate nodes will carry your messages, right? So the message will be carried by the intermediate systems, right? So there is no dedicated path between the sender A and B, right? And there is no establishment. So here it is given, no establishment of dedicated path between the sender and the receiver, and the destination address is appended to the message. So since there is no path, then how the packet will be transferred? Think of it. So you need to provide the address, right? You need to provide the destination address upon receiving. So when node B is receiving like this, right? So think of this. So there are two intermediate nodes, right? 1 and 2. There are two intermediate nodes in between the node A and B, right? There are two intermediate nodes. So once A is sending a message, then the one is receiving that message, right? Think of that. One is receiving that message, and one has to forward to B, right? But it does not know what is the destination address. So this is called the dynamic. Upon receiving that message, it is going to look about where it has to transfer this message. That is the message which is received from A, right? So upon looking at the address which is attached into the message, right? And then it finds another node. So based on the address given, it finds another node and it forwards the message to the next intermediate node, which is a node 2 now, right? In this scenario, I'm talking about this scenario, right? In this scenario. So upon receiving that message, the 2 is looking for the address and then it forwards to the next intermediate node. Likewise, the message is forwarded to the destination, right? Like this. Once the message is sent from the sender, then it is going to be forwarded by the intermediate node. So the intermediate node has the responsibility to forward the data. So once it receives a message, until it transfers that message to the next intermediate node, then it has to store that message. So it has a control over the message and it has to store the message until it delivers that message to the next intermediate node. Is it clear? So it has store and forward. It is said to be store and forward circuit switching. So store and forward switching, right? This message switching, it is also called store and forward switching. Is it clear? So until it delivers to the next intermediate node, it has to store that message. So nothing else until it finds the next intermediate node and next intermediate node to transfer that data, it has to store. So that it needs some space, right? So there is a need of some resources to store that message, right? So that it has a control over the message, right? Is it clear? So once it finds the dedicated path, then will be handed over, right? So the message will be handed over to the next next node, right? Is it clear? Are you listening? Is my voice audible?
Yes, ma'am.
Oh, okay, good. So there are two things. One is store and forward, and another one is the message delivery. How the node will come to know where to send the message based on the address which is given in the packet, right? Not packet, message, right? So based on the address which is present in the message, it is going to deliver the message, right? So that it is called the dynamic. It performs dynamic routing, right? Once it receives a message, then it is going to finalize where to send this message to next, right? Where to send the message, right? So it decides, then only it decides where to send this message, right? So that it is called as dynamic routing. So there are two things. One is store and forward, and another one is the message delivery, right? Is it clear? So, in message switching, the entire information is compiled into a single message, right? But when we go to packet switching, which is split into multiple packets, let us see what is that. After a few slides, so message delivery in message switching, the entire information, right? Entire information is compiled into a single message. So you are going to send a single message, right? So you are going to send a single message. So there are some intermediate nodes. So message 1, which goes like S1, S2, S3, and S6, right? From sender A to B, which goes through S1, S2, S4, and S6. For message 1, there are 4 intermediate nodes, right? S1, S2, S4, and S6. And for message 2, it goes in such a way, right? Which is given in blue line, right? And next one is, so what is, so here each and every node stores the entire message. So whenever each node receives the information, then it has to store the entire message, and then it forward to the next node, right? And so which works, each message which is works as an independent entity. The single message will be considered as an independent entity. And what is the advantage of message switching? Data channels. So data channels are shared among communicating devices, and traffic congestion can be reduced. The message is temporarily, since the message is temporarily stored in nodes, and so the same point can be given as disadvantage, right? Since it needs, since each node that has to carry the message, then it needs a resource, right? And what message priority can be used to manage the network. So whichever has the highest priority, that can be sent first, and the lowest priority can be sent next. So size of the message which is sent over the network can be varied. Therefore, it supports data of unlimited size, right? And what are the disadvantages? Disadvantage, each node which is need to be equipped with a sufficient storage, right? And long delay can occur due to storing and forwarding facility, right? So it has to store, and then it has to find the next node which needs to be carried that message. And until if the node 3 is not free, right? Node 3 is not free, then it has to wait until the node 3 becomes free, then it has to forward the message to node 3, right? So that there might be some delay might occur, right? And what is about packet switching? Packet switching, which is the technique. So this is the third kind of switching, right? We are looking about switching technique. One is circuit switching, next one is message switching, and third one is packet switching, right? So packet switching, which is a switching technique in which message is sent in one go, right? So which is divided into smaller pieces. They are sent individually, like a packet, right? The piece of information which is called as a packet, and each packet will be given with a unique number. So at the destination, the packets will be reordered, right? By putting a unique number in each packet, we can reassemble at the receiver side, right? So at the node B, the packets will be reassembled. By looking at this, you can better understand. So A is sending the message. The message is split into number of packets, and packets are assembled. Packets are given with a unique number, so it takes a different path. So each packet will take a different path. What is the difference between message and circuit? In message, we used to have a single message. The entire message will be compiled into a single message. Here, the message is split into number of packets. Each packet will take a different route, right? There you can observe the message 1 takes a different route, and message 2 is different from message 1. It takes a different route, right? But here, the message, so single message is divided into number of packets, and each packet takes a different route to reach the destination B, right? Is it clear, ma? Are you all listening? Is my voice audible?
Yes, ma'am.
Is it audible, pa? Yeah?
Yes, ma'am.
Sorry, I couldn't get you.
Yes, ma'am.
Okay, fine. So this is the way the packet switching is bought. And let's move. What are the types in packet switching? Let's move and see. So packet is reassembled. What is the advantage of having that unique number, appending a unique number in each packet. So thereby we can see whether any packet is missing or corrupted, right? And if any missing packet is there, then that can be resent again, right? So there are the packet is split into 1 to 4, right? Splitting the packet into 4 information into 4 packets, and which are with a unique number. Each packet is assigned with a unique number, and at the end it is going to be reassembled, right? And at the end it is going to be reassembled. By reassembling the messages, once you reassemble that packet, then you can identify whether any packet is missed, right? If any packet is missed or corrupted, then the sender can resend it by receiving the acknowledgement. Otherwise, without receiving the acknowledgement, if the acknowledgement is not received within the limited time period, then the sender will resend the packet, right? So, and which is also used to make sure about whether the packet is reached at the destination. And these are there are 2 approaches. One is the datagram packet, and another one is wait a minute. One is datagram packet approach, and another one is virtual circuit switching. Virtual circuit switching. Yes, this one, the virtual circuit switching. So in datagram packet approach, let's see what is that datagram packet. This is one kind of packet switching, right? Datagram packet switching is a kind of packet switching, and which is considered as independent entity. So commonly all the data unit, right? So we used to send the packet, so will be considered as an independent entity. Each packet contains the information about destination, and which uses this information to forward the packet to the correct destination. The packets will be reassembled at the receiving end in correct order. In datagram packet switching, the path is not fixed, right? Intermediate nodes take a routing decision to forward the packet. So datagram packet, which is also known as connectionless routing. There is no dedicated path will be given path. There is no dedicated path. See, so intermediate nodes will will make a decision about the path, right? So each packet is basically an independent entity, right? Will be considered as an independent entity, right? And which is also called as the connectionless packet switching, right? Since why it is called as a connectionless packet, since the packet switch does not keep the information about the connection state, right? So packet switching in the datagram packet switching, the path is not fixed, right? The path is not fixed, and it does not maintain about the connection state. That's why it's called as connectionless packet, right? So routing decisions are taken by the intermediate nodes, right? In order to forward the packet, the routing decisions are taken by the intermediate nodes, right? Intermediate nodes. And what to say about on the receiving node, right? On the receiving node, so all the packets will be reassembled. Here in datagram, all the packets will be reassembled to get the message in a proper order, right? And what is about virtual circuit? Virtual circuit. So this is these are advantage of having packet switching network. I think this slide has to come forward. Packet switching, okay? Virtual circuit switching. Let's see what is that virtual circuit switching, which is a connection-oriented switching. So datagram is connectionless, and virtual circuit is connection-oriented switching, and which is a pre-planned route, right? There we don't have any plan for routing, right? So since the datagram does not maintain the connection state, it is called a connectionless. Here the virtual circuit is connection oriented, and it has some pre-planned route for sending the message from one to another node. And call request and call accept packets are used to establish a connection between the sender and the receiver. There are 2 packets. One is the call request, and another one is the call accept. There are 2 packet or send. One is call request, and another one is call accept, right? To establish a connection between the sender and receiver. This since it is a connection oriented, right? It's a connection oriented. So there's a logical connection exists between the sender A to sender B upon sending the call request and call accept request, right? Call accept packet. This is a call accept is acknowledgement, right? So once the accept is given by the sender, there is some dedication connection between connection exists between the sender and the receiver, right? So a path is fixed for the duration of a logical connection. So this path is fixed for duration of a logical connection, so that they can so the both systems can send and transfer the data. All right. So here also we are going to say the kind of data transfer unit is packets, right? In packet switching, you are going to send the data as packets, right? So splitting into number of packets. The original information will be split into number of packets. Then it has to be transferred, right? So each path will take a different route, but it is going to be fixed, right? It is a pre-planned route. It is already it will be planned by the router, right? Is it clear? So there will be some routing tables there. They can find the path where to. So when the intermediate node is receiving receiving the packet, then it has to decide where to send the packet, right? So here the decision is already fixed. So the node is not going to decide it where to send the packet, what is the destination for this packet. It is already given, it is available in the routing table. From the routing table, it is going to find out, by reading the routing table, it is going to find out where to forward this packet next, right? So that is about virtual circuit switching, right? And advantages of packet switching, which is cost effective, reliable, and efficient. Cost effective, since it does not require a massive storage, there is no forward and carry. Forward and what to say? In circuit switching, we had a term storage and forward, right? So here we don't need to store the data, right? The intermediate nodes will just transfer the packet, right? We'll send the packet to the next node, right? There is no secondary storage which are needed to store the packet, so it is cost effective. And the reliable, also it provides reliability, right? If any node is busy, then packets can be rerouted. So there it has to wait, right? So in what? In message, otherwise message switching, it has to wait for some more time until the device is idle, right? If the device is busy, it has to wait for some more time until it finds idle. So once it finds idle, then it has to forward the message. But here it can be rerouted, right? And efficiency is also good. In packet switching, it is an efficient technique. So it does not require any established path period to the transmission. So many users can use the same communication channel simultaneously, so that it is efficient. And these are some of the difference given for datagram approach and virtual circuit approach. All right. And disadvantage of packet switching. What is the disadvantage? It incurs low delay and high quality services, require low delay, right? And protocols used in packet switching technique are very complex and requires high implementation cost. And overall, if the network is overloaded or corrupted, then it requires a retransmission of lost packets. Since it's performing retransmission, if any failure occur in between the transmission, then it requires retransmission of packets. So that are given as what a disadvantage for packet switching, right? So with this, we complete unit 2. So packet switching, there are 3 types in packet switching. One is message and circuit switching. The first category is circuit switching, second category is message switching, and third one is packet switching, right? Is the class clear, Pa? Can you follow the class? What happened? I don't receive any reply. Anantu, Ankush, Saidattu, Anirudh, Nikita, Akshita.
Yes, ma'am.
Yes, ma'am.
Okay, next let's start unit 4. Okay, so unit 3, which comprises of some mathematical problems. For error correction and flow control, which involves some mathematics problems. So that let's start unit 4. Okay, let's start the unit 4, and after we come to offline class, then we shall start unit 3. Okay. So before that, let's try to finish unit 4. Okay. Unit 4, which is medium access control. Just will give you introduction what is medium access control, and in the next class let's look about what is that. Okay, just will give you the introduction. Media access control. So this is going to talk about the data link layer, right? Data link layer. So what is data link layer, which is the second layer, right? Data link layer is second layer and is used in, which is used to transmit the data between two devices, otherwise we can say two nodes, right? So as we have seen about data link layer, which is which consists of two layers. One is the logical link layer and another one is the media access layer, right? So we are going to look about the second layer, so which comprises of two layers. Data link layer, which comprises of two layers. One is data link control and another one is multiple access resolution. Otherwise we can say media access layer, right? Multiple access layer or media access layer. So this fourth unit, which talks about what is this media access layer and what are the protocols which are used for. So that's about the fourth unit, right? And data link layer, which is given in third unit, data link control, right? Data link control. Otherwise, we can call it as logical link layer, right? Media access layer and logical link layer. So this logical link layer, I hope you could remember the logical link layer. What is the functionality of logical link layer? Flow control, error control are all functionalities of logical link layer. Collectively, we have seen that data link layer, which is supposed to perform on the flow control, error control, access control, right? So how the access control can be done at data link layer, which is that corresponds to the multiple access resolution, otherwise the multiple media access layer, right? So let's see that. I've prepared a PPT. Will forward in your group. We'll send you the PPT. Okay. So up to the last class, I have uploaded all the PPTs. Please go through the Google Classroom and make use of it effectively. Okay. Anything else? Is the class clear? Can you follow the class, Pa? Adesh, Mahant, Akhil, Akshita, Pallavi Teja.
Yes, ma'am, the class is clear.
Yes, ma'am.
Okay. Mahant. Akhil, okay.
Mic is not working.
Oh, okay. Akshita, ma? Akshita,
Yes, ma'am.
how's the class going, ma? Is it clear?
Yes, ma'am. It's clear.
Okay, good. Roll number 11, Shanmugam. Sorry, what is the name? Is it clear, pa? Shanmugh, sorry. Shanmugh, okay. Is it clear, ma? Can you follow the class? Up to now, we have completed 2 units, pa. Okay? So please go through the PPTs available in Google Classroom. To everyone, I am intimating this, okay? Harish, Ganesh, how do you feel about the class? Is it clear, pa?
Yes, ma'am.
Ganesh, okay. Harish, what happened to Harish? Sritya, Jarin,
Yes, ma'am.
yeah.
Yes,
Okay.
ma'am.
Jarin, okay. Kalai,
Yes, ma'am.
okay. Is it clear, ma? Are you having any trouble in listening the class? Otherwise, having any doubt in concept? If you have any doubt, you can send to my WhatsApp number, okay? Sai Dattu, who is that roll number 26? Roll number 26, I couldn't get your full name.
Yes, ma'am. Bharat.
Bharat, okay. Bharat,
ma'am.
is it clear, Bharat?
Yes, ma'am. It's clear.
Okay. Preetam, Manish, Nitin, Nagaraju, Naveen.
Yes, ma'am.
Yeah, okay. Prishav, roll number 47 and 48.
Yes, ma'am.
Okay. 48. Can you follow the class? Is it clear?
27 present, ma'am.
Okay. Somesh, Srinath, Sriman, Sujana, Sundaravadivelan.
Yes, ma'am.
Okay, pa, okay. Okay, Swati, Sushmita, Swati Jain. Okay, time is 12 now. I have to end up the class. Okay, let's meet in the next session. Bye. Thank you. Let's start at the 4th unit. Okay. Okay, ma'am. Bye. Thank you all. Thank you.
Thank you.
Thank you,
Thank you,
Nisha.
ma'am.
Yeah, thank you so much.
Thank you.
Thank you. Thank you.
Thank you, ma'am.
Thank you, pa.